Hi everyone, I'm Sir Mel and welcome to Mathematics in the Modern World. If you are new to my email channel, please don't forget to subscribe and click the bell button for more notifications. Today we're going to discuss problem solving and recreational problem. So let's get started with the problem number 1. Okay, let us read together. Given E is the midpoint of M and L. If ML equals 40, ME equals 2x, what is the value of x? So let us try to figure it out by simply draw a line which has a midpoint E. Then the endpoints are M and L. The measurement from M to L is 40. ME is 2x. So we're going to find the value of x. Okay, so this time we're going to consider the definition of midpoint or DOM, which means the sum of ML is equal to ME plus EL, where ME is congruent to EL. In short, ME equals EL. So this time we're going to bring down all the given. ML equals 40, ME is 2x. This time EL still 2x since ME equals EL by definition of midpoint. Then we can do the addition. So combine like term, we have 4x equals 40. Then we're so concerned with the value of x, we're going to multiply whole equation by the inverse of 4, which is 1/4, distribute it, and we're able to find the value of x as 10. If we want to check whether our answer is right or wrong, let us try to substitute 10 to 2x, which is 2 times 10 is 20. And 20 plus 20 gives 40. So meaning to say the value of x, which is 10, satisfy the given problem. So let's proceed with the second problem, and this is given E is between M and L. If ML equals 7y minus 4, M equals 3y, and EL equals 28, find the value of y. So again, let us try to figure it out. So we have line, and the point is E in between of M and L. The measurement of ML is 7y minus 4, M is 3y, and EL is 28. So again, let us consider the definition of betweenness to find the value of y, which is ML equals ME plus EL. So meaning to say, we're going to add ME and EL to get ML. So bring down all the given by substitution. We are so concerned with the value of y, so we're going to transpose 3y to other side, it becomes negative 3y. Negative 4 to the other side, it becomes positive 4. So we have 7y minus 3y equals 28 plus 4. So we can add variable to variable and constant to constant. So we have 4y equals 32. Then we're going to multiply whole equation by the inverse of 4, which is 1/4, distribute it, and we're able to find the value of y, which is 8. Again, if we want to know whether our answer is right or wrong, let us try to substitute it to the given problem. So we know 7 times 8, which is the y, minus 4 is what we call 52. And 3 times 8 is 24, plus 28 is also 52. So y equals 8 satisfy the given problem. Okay, let's move with the third problem. We have L, O, V, and E, or love, are points on a circle. Each of these points is connected to each other by a line segment. How many line segments are there? So let us try to picture out it. So we have circle, and there are 4 points lies on that circle. So problem is we're going to find the number of line segments if we try to connect these 2 points. But we need to consider this formula. So let n be the number of letters. So LOVE, count it individually, so we have 4. Then substitute given formula, so we have 4 times 4 minus 1 over 2. Then 4 minus 1 is 3, so we have 4 times 3 over 2. Then multiply it, we have 12 over 2. Then the quotient is 6. So meaning to say, if we have LOVE, our points on a circle, then we can create 6 line segments. Now let us do the actual. So if we try to connect LO, that is 1, LB, that is 2, LE is 3. We still have OV 4, BE 5, and we have EO or OE 6, which means this formula will satisfy the given problem. So meaning to say, if the number of letters increase, still you can apply this formula. Okay, so that is how we are able to solve the problem number 3. Let's move with number 4. Okay, here find the value of x. 3 times x minus 2 equals 5x minus 12. Let us have solution and reason. Okay, first is, of course, bring down the given. And we're going to multiply 3 to the term inside the parentheses. So we have 3x minus 6, bring down 5x minus 12 by distribution. Then we're so concerned with the value of x, we're going to transpose 3x to other side, become negative 3x, and negative 12 to other side, positive 12. So we have 12 minus 6 equals 5x minus 3x. So we can subtract 12 minus 6 and 5x minus 3. So we have now 6 equals 2x. So we're going to multiply whole equation by the inverse of 2. We have 1 half. Then distribute. Then we know 2 divided 2 is 1. So x equals to 3. If we want to check whether our answer is right, let us use the value of x, which is 3, and substitute it to the original equation. So we have 3 times 3 minus 2 equals 5 times 3 minus 12. So we know 3 minus 2 is 1. 1 times 3 is 3 on the left side. On the right side, 5 times 3 is 15 minus 12, which is also 3. So we need to say the value of x, which is 3, satisfied the given problem. Okay, let us have another example about this, finding the value of a known. So we have here 5 times 2y minus 3 equals 8 plus 5. Do the same process, bring down the given. Then multiply 5 to the term inside the parentheses. We have 10y minus 15 equals, bring down 8y plus 5 by distribution. Then we're going to transpose 8y to other side. It becomes negative 8y. Negative 15 to other side becomes positive 15. So we have now 10y minus 8y equals 5 plus 15. So 10y minus 8y is 2y. 5 plus 15 is 20. So again, we're going to remove 2 by simply get the inverse of 2, which is 1 half. Then distribute it. Then 2 divide itself, which is 1. So y equals to 10. Again, if we're going to find whether our answer is right or wrong, let us do the checking. Let us try to substitute 10 to all the y's in the given original equation. So 2 times 10 is 20, minus 3 is 17, then 17 times 5 is 85, equals 8 times 10 is 80 plus 5 is also 85, which means the value of y, which is 10, satisfies the given problem. Okay, let us move with the problem number 6. So how many intersections do we have when there are 18 lines to be intersected each other? Okay, so this time we're going to identify the number of intersections if we're going to draw number of lines. So let us put it in this way. If we have 2 lines, the number of intersection is 1. If we're going to draw another line, the number of intersections becomes 3. So, using this formula, let us try to validate, or let us try to check whether this formula will satisfy the given figure. Okay, so again, we have 2 lines. So 2 times 2 minus 1 over 2. 2 minus 1 is 1. 1 times 2 is 2. 2 divided 2 is 1, which means 1 intersection. Then if we're going to draw another line, so n becomes 3. So 3 times 3 minus 1 over 2. 3 minus 1 is 2 times 3 is 6. Divide 2 is 3, which means it will satisfy the given problem. In short, in our problem, we have 18 lines. So let n be the number of lines, which is 18. Use the formula. 18 times 18 minus 1 over 2. Then simplify it, multiply it, then the quotient is 153. Therefore, if we have 18 lines, the number of intersections between that lines can be solved using n times n minus 1 over 2, which is 153 intersections. Okay, so let us have the number 7. If 9 plus 5 equals 6, 9 plus 7 equals 11, 6 plus 8 equals 18, 3 plus 9 equals 24, then what is 7 plus 9? So again, be careful. It is a if-then statement, which means conditional. It is only true in this problem because we know 9 plus 5 is not 6, rather it is 14. But in this case, if-then, it's only true in this problem. So let us put the solution in this way. Okay, so we're going to find the pattern as we try to examine each line. Okay, if we're going to assess 9 plus 5 equals 16, what would be the process or pattern to be applied here? So let us try to use this. 3 times 5 minus 9. So meaning to say, we're going to multiply the second digit by 3 and subtract it to the first term, which is the 9. So 3 times 5, which is 15, minus 9 is 6, will satisfy the first row. Let us go to the second row. Do the same process. So we're going to multiply 7 by 3 and subtract it to the first. So we have now 3 times 7 minus 9. And we know 21 minus 9 is 11. That still satisfies the second row. Let us go with the third. So 8 times 3 minus 6. Okay? And 3 times 8 minus 6 is 24 minus 6 equals 18. Still satisfied. Then the last is we're going to multiply 9 by 3 and subtract it to 3. So 3 times 9 minus 3. And we know the product is 27 equals 24. So this time we can solve the 7 plus 9 by multiplying 9 by 3 and subtract it to 7. And our final answer is 27 minus 7 equals 20. So in short, in this kind of conditional problem, if then, the best way to solve it is try to find a pattern that will satisfy in all the rows in a given equation. Okay, so that is number 7. Let's move with the problem number 8. Okay, this would be the last. So let us read together. You take a survey with 5 yes or no answers. How many different ways could you complete the survey? So by the way, how many questions that you need to answer? There are 5. So let us have this table. So we have items, which is 5, 1, 2, 3, 4, 5, and each item you can answer it either yes or no. Okay, so it's so clear here. Let us have to express it in a diagram. Okay, in item 1, the possible answer is either yes or no. That is 2. On the second item, we can yes, no, yes, no. So becomes 4. On the third item, yes, no, yes, no, yes, no, yes, no, yes, no. That is 8. Meaning to say, if this would be the pattern, we can apply this formula. Capital M to the power of n. So let n be the number of items and small capital M be the number of options. So in our problem, 5 is the number of items, yes or no is the number of options. So let us try to identify that 5 is the number of items, that capital M is the number of options. We're going to solve it, the formula. We're going to use the formula to solve the number of different ways. So 2 to the power of 5 and 2 to the power of 5 gives a product of 32. Final answer. So meaning to say, if the problem needs to know the number of different ways that you could that you could complete the survey, you're going to use this formula even in a multiple choice. Example, if we have 3 items and each item has 4 options, so therefore you're going to solve it as 4 to the power of 3. 4 times 4 times 4 is 64. Okay, so that is how the m to the power of n works. Okay, so thank you and God bless everyone.